Welcome to the final grand rounds for 2024. I'm Ruben Pillay. I'm the Executive Director of the Helsinki Institute of Biomedical Innovation, also Assistant Dean up here in the School of Medicine. We're really honored to have today with us a friend and colleague, Todd Dunn, who has a pretty impressive background in innovation. That goes back several years. So Todd has a substantive experience in the corporate world with, amongst others, GE and McKesson. I met him when he was the Chief Innovation Officer of Intermountain. Yeah, and he was a founding member with me of the Health Innovation Professional Society. So I've always followed Todd's work with keen interest. He's a highly respected and quoted consultant and author. And we're really pleased to have him today to talk about a system that he's been integrally involved in the development of, and obviously driving the use of it. So with that, Todd, I'd like to hand this over to you to introduce your solution to us. Thanks.
Thank you. Thanks for having me. I'm actually also the president of the Ruben Pillay Fan Club. We've known 6 years now of great sharing of learnings and things that we think are pragmatic to the improvement of the quality and the cost of care. So we're going to talk a little bit about AKI, CAUTI, but Ruben and I have talked so long about this systematic way that I think about innovation. And so I'm going to talk about how we discovered and understood the problem before we really went after and sought a solution. So if we can get Danica, I think you can help me advance slides. So we're going to talk about it as soon as we get the slide to move. Sorry for the delay. So a little bit of story. My aunt and uncle lived in Homewood, so it's good to kind of be home. For my entire life, they lived just close by. And Danica's helping me. 1 second. There we go. So in 2008, Christopher Charles decided to move from the comfort of his home in Canada to Preek-Rousset. It's a village in Cambodia. And why did he leave there? Because he was a researcher and he wanted to know more about water quality in Cambodia. And so that's where he moved. He slept in one of these huts 12 hours a day under a net, but the other 12 hours of the day he was out fishing with people, having dinner with them, sipping on tea. And when he was there, he went to study water quality, but one thing he noticed when he was there was people were incredibly lethargic. And he knew going in that there was an anemia problem in that part of the country, but he didn't know to the magnitude of what. And when I was talking to him about this, he said, Todd, everyone would come in out of work and they'd just lay around. That's all they do the rest of the day. They were just wiped out. He said, so I decided to do something about it and change my focus a little bit to testing people's blood. So this is Chris. He'd been out fishing. They figured out a way to test blood. If you see some of the back end pictures of this in American medicine, it would make you a little bit nervous. But they drew blood. And what they found was over 85% of the people in that area was severely iron deficient anemic. That was the problem. And so he did more research. And for those of us in the South, especially who like to eat cornbread out of a cast iron skillet, that's actually good for you, by the way. They proved starting back in the 70s that if you ate food that was cooked in a cast iron skillet, some of it would leach into your diet, which would go in your body and was good for you. And so if you know about that part of the world, Amazon Prime doesn't deliver there, by the way. And they didn't have the money to switch over to cast iron pots. And so he thought, what can I do? Well, I'm just going to make something like a cast iron pot. So he made this. This is an ingot, is what it's called, and it's out of cast iron, the same type of cast iron you would cook in your kitchen. He made this and he gave it to people. Now remember, he's in Cambodia. He's having dinner with people and he wants them to put this into their soups and teas, but what do you think they actually did with it? They used it as a doorstop. I have pictures of it as a doorstop, holding up books, and even as a coaster on their table. They would do nothing with it. And so Chris told me one day he was waiting for a ferry to go to another island to test blood on that island. And he looked over and there was an older gentleman carving a fish out of wood. And it hit him. Duh. Fish are very important in the culture. So he got back the next day, he went to the fishmonger. And he asked the fishmonger, he said, what's the most popular fish in the area? And it was a cantrope. And he said, people consider it a lucky fish here. So Chris had an idea. Culturally, this is very important. So he designed that ingot into that, which is now known as the lucky iron fish. And because he's a researcher, he's now an anesthesiologist, he gave people this. And they put it into their soups and teas and they tested blood. And they have research papers on this, he and Gavin Armstrong, that show that by putting this into their soups, that it alleviated severe iron deficiency anemia in some of the people. But this was important. It's a happy fish, as you can see the smile, and it was culturally important. So you take that old ingot, that was an assumption that they would do it because it's good for them, but then you make it culturally relevant and they used it. There's nothing different in the material of it, only the culture piece of it. But he learned this because he was there. He was in Cambodia with the people, and this is one of the pictures that he gave me. That's about the size of it. I have one in my backpack. They put it in there. But then they also knew that this was a problem in India. And so they took the fish to India, and what do you think happened in parts of India with the fish? Nothing. Because a very large part of that population is vegan. They do not eat any animal product whatsoever. And so they went there and they created this. This is called the CAUTI leaf. Now, the important part of what I'm sharing is that he left Canada to go to Cambodia. He left there to go understand the context. Chris committed 6 months to Cambodia. He stayed 3 years because he was that deeply interested in serving and helping people, which I think actually the empathy is the heartbeat of healthcare all over the world. And so that's what he did. He gave up his life to go help with this. And this organization, you can look it up today, called the Lucky Iron Fish. You buy a fish and you give one away in the world. You can buy to give them away to these areas of the world that actually need it. And I have friends who I've told this story, and their daughters were anemic, and so they do these in their kitchens in the US because it actually helps. But go to Cambodia. There's a theme here that we really have to understand. And this is what, when I heard this story, I thought it hit me. What Chris did is he just followed the principles of medicine. He diagnosed before he prescribed, right? He went there. He didn't try to prescribe something from the comfort of his home in Canada doing Google research. He actually went to Cambodia, gave up so much of his life to go help people. And so as an innovator, and Ruben and I have had many discussions about this, what is the method of innovation that we need to follow that parallels medicine, right? Because researchers are the reason that medicine is so much better today. So how can I become an innovative researcher or a researcher who does innovation? And so we created this. I call this the innovator's method. And you can see that the left side of this is really about diagnosing the problem. And this is kind of what Ruben wanted me to talk about. It's like, how did you figure out what to do about the problem? Well, this is what we did. And so we got a current state understanding of acute kidney injury in the kidney by looking at codes, data, you name it. And then we went into the context. You'll see some pictures. I spent a lot of time in ORs, ICUs, interviewing patients, ride-alongs, you name it, with my team because we wanted to understand the problem just like Chris did. And we had this theme that we call Go to Cambodia. So we were going to Cambodia, but we lived in Charlotte. But it was this whole notion of empathetically going to learn from and with people. But then you can build something that anyone would love, but you might not be able to afford to do it. So you have to do business model research. And notice I didn't say business planning because a lot of times business plans are built on assumptions. Well, you can't prescribe on an assumption, you have to prescribe on a diagnosis. So we thought, what are the diagnostic tools of being a great innovator? And then I studied again. Anybody know who this guy is? By chance. This would be like, this is a 1,000-point question on Jeopardy. This is Louis Pasteur. One of the only people in the history of the world that has a verb named after him. Interesting. But what I really respected from him and other men were this notion of the germ theory. The germ theory was just a belief of what caused germs to magnify, right? You remember this story? These people were getting sick. They thought it was because of the puddles on the mud roads in Europe. And what they figured out, that's not really it, but he had this theory. Well, germ theory, cell theory, all these theories are really the reason that medicine is what it is today. Cell theory helped us understand how the body worked. Germ theory helped us create vaccinations. The first one was rabies. And of course, if you look at any other vaccination, it came out of this theory work. So I thought, well, if medicine uses theory as part of the kind of diagnostic rigor, what should I do as an innovator? Well, then I need to figure out a theory or find one that will help me understand people and their context. So I happen to have known Clay Christensen when he was alive, and he and his colleagues created a theory called the jobs to be done theory. And the job is just the progress that someone is trying to make in a particular circumstance. So this morning we met with Dr. Nehra. He's a nephrologist. The circumstances of his world are very different than someone in an ambulatory setting. And so what Clay and colleagues said is you really need to go there because circumstance is the essential unit of innovation, and people make progress on 3 levels. And when I tell you these, you're going to see exactly why Christopher was successful in Cambodia. The functional problem is just the problem I'm trying to solve or the task I'm trying to complete. The emotional dimension of this is how do I want to feel when I'm making progress? And safety is a big feeling, right? How do I feel safe when I'm delivering the medicine? Do I safe when I deliver the care? The social dimension is how do I want to be perceived? The social dimension of the fish was more important than the functional dimension to get people to use it. The ingot was not good. The fish had the social context to how do I want to feel about putting this into my soups? Well, we decided that we were going to use this framework for going in and following people, but there was another input that we really wanted to know. So we had these corporate measures, but what we didn't have is Heather's measures or Alan's measures. And so this is what I call a love metric. And so we went into, like again, the ORs, the ICUs, the kidney dialysis units, and we wanted to understand what was the customer benefit metric that they were looking for that they cared about. Like, what are you really struggling with and how would you measure something? If we were to give you what you love, called the love metric, what would you love to have? And we kept hearing, I would love to not have to document this stuff. I would love not to have to milk the Foley. I would love to know actually what's going on with urine without having to be in the room all the time. There are all these things they were telling us because they had all of this friction, and we would write those down. Because that to me is the ultimate input to great design and the essential element of change management. Because if I can design to what Carlos is trying to do and what Carlos is measuring in his environment, then it's easier to help Carlos through the change. Because I don't need Carlos to change. I need him to he wants a better place. And knowing that measure was a key input for us. And then of course there's this. This is called a business model canvas. And as an innovator, I will tell you one of the most misunderstood terms in innovation is business model. I did this thing one time. I said, if I ask 100 people what their definition of business model is, how many answers would I get? And the answer was always 100. Well, if we're all talking about building business models, but we're all talking about it a different way, then we're kind of in trouble. It'd be like saying stat on the floor and everybody has a different understanding of what stat means. Carlos thinks it's 5 minutes and you think it's 5 seconds. Well, Carlos is going to be having a cup of coffee and you're going to be screaming at Carlos. It's the same thing in business model work. And so a business model is the way that a company is organized to create, deliver, and capture value. This is a tool of innovation. And there are 3 sections: desirability, feasibility, viability. Desirability is all about you. It's all about the person and their context and what progress are they trying to make. Feasibility, I sometimes call the operating model. What are the activities you have to do? What are the resources you need? Who are the partners that can provide those activities, resources, or channels? And then viability, we all hear it in healthcare and we all get bothered by it, but it's a necessary element. Can we afford it? And so many times innovation is built on what I call the field of dreams theory. The Field of Dreams is a baseball field in the Midwest. Everybody's heard about it, watched the movie. What most people don't know is it went bankrupt twice. And I'm a baseball guy. My boys are really good baseball players. And I say you can't have a Field of Dreams type strategy. It has to be viable. And you've got to do desirability, feasibility, and viability. And you can do it as long as you talk about it in the exact same way. And so if you parallel back to what Chris did, he really understood viability, he understood feasibility, and he understood desirability. He understood all of them at the same time. Well, we can too, but that's the lens, that's the method. The innovator's method was going to the context and learning, writing down through a theory framework everything we believed about the person in their context and everything we believed about the business model, and then we ran experiments. So it's just a scientific method applied to innovation. And if you do that depth of work, you go see, you come back, you learn, you go see again, you do research, you have a hypothesis, sometimes you're wrong, sometimes you're right, but that's why we do the rigor of work. And I think innovators need to do the same, and that's how we figured this out. So this is one of the pictures that we took. I was following a dialysis nurse. And I was like, can I please take your picture? Because he had to lug these big old machines around. He's about my age, mid-50s. I'm a little later 50s. His back hurt all the time. But we were painting this movie of the kidney from the OR to the ICU. And then sometimes you have bad AKI, so you got to go on dialysis. And we really wanted to know it, but we watched what he struggled with, and we took copious notes along the entire part of the journey. And then we saw this. This is the thing that might have intrigued me the most. We know the inputs into the body down to the milliliter, and we know them constantly, all the time. But the outputs, we don't know that well. And so it leads to things that are not good. We're guessing, we have inaccurate data and those type things. You already know this because you're clinical people, you see this. But what I couldn't understand was the contrast between the digitization of the heart, lung, and brains and the manual work and understanding of the kidney. I just didn't understand it because I'm not a doctor. My daughter's in med school, but that doesn't qualify me to be a doctor. And so I would write these things down, and my team would say, look at the things that stand out to us because we don't know what to look for. And we wrote these things down. And then we saw this. Everybody has seen this if you're in an ICU, like these gravity-fed Foleys. It's very manual. And you've got to milk the Foley, and you've got to manually write down the urine. And nurses have to do this, and ICU nurses, one study said they have about 125 tasks per hour. And so I was exhausted following them all day in the ICU. I never got to talk to them because they're too busy to talk. So I just had to watch. And we wrote these things down like, wait a minute, there's a lot of limitations to this, and that's not fair. And we kept thinking, there has to be a better way. There has to be a better way to do this. And then we saw these. We've all seen these. This is called a dependent loop. It's when urine stops moving. Well, that's a problem because the body's supposed to keep things moving, but the Foley doesn't. And so you get these dependent loops, and it creates weird pressures in the body. I won't go into it. I know more about it than a non-clinician probably should, but that's a problem, and nurses don't like milking Foleys. They don't like doing it. It's not a pleasant thing for them, and it's not a pleasant thing for the bladder. And so you see these. These are gravity-fed Foleys. And so we kept thinking there has to be a better way. We kept looking for friction, and we kept looking for friction and interviewing the experts, the trauma surgeons, the CRNAs, the ICU nurses. We just wanted to learn everything we could. Go back to the innovator's method. We were diagnosing every part of the problem. We were pulling the codes and looking at how many AKI diagnoses we had because we wanted to understand it so that when we went to the value committees, we could pass the sniff test. Then we saw this. I call this the MacGyver. I know this isn't what everybody uses, but this is kind of an outdated, archaic way that's still used to get intra-abdominal pressure. Well, you need to know it. When your pressure gets too high, it's not good for the things inside the body, but that's what is being used at a certain system to get intra-abdominal pressure. It's so inconvenient, you have to recalibrate it every time. Nobody wants to do it, but you need to know. So we kept saying again, there has to be a better way. And I was in the hospital with my good friend, Dr. Christine Sisk. I think she's on vacation, so she's not watching. And she looked at me and she said, you need to help us find a way to manage urine. That's your job as an innovator. You got to help me. You've been spending time in the OR and the ICU. And what she said was replace my barred Criticore. Remember those machines that they took off the market that were urinometers that weren't accurate, so they got rid of them? And so she sent me on a hunt. She's like, okay, now we know the problem, go find me an answer. So I did. I found that. I had known about it for a few years, and that's what Alan and Ashton are going to demo here in just a second, is I found a device that automates urine flow. It gives you intra-abdominal pressure. It's accurate urine output measures back into the EMR. So it basically digitizes the kidney. And then I'll close with this and turn it over to Alan for the demo. as an innovator, I don't believe that I get to call myself an innovator or a transformation person. I don't think that's a title I can give myself. It's not. I think the only thing that can give someone an innovation title is if they implement something with a person who's going to use it in their context and they love it. If not, you're just busy. You're wasting people's time and money. And so I was doing observations in the flagship hospital, and that Accurate device was sitting on the floor in the nurse's office. It said, do not remove from the CT ICU. And then I knew we nailed it, because the nurses were pulling it into their workflow. They were taking it to the bedside. They were using it. And we had nurses from other floors, before we put them out throughout the entire hospital, coming and taking them. And so they felt compelled to say, do not remove from the CT ICU. And so this all goes back to the principles of medicine of diagnose before you prescribe, understand the circumstance and the context. And we were just gifted to spend so many hours understanding the data and the context of the people who were dealing with this problem of basically manually managing the kidney. And so this is the brilliant answer to all the struggles that you saw. And Alan's an ICU nurse, so I'm going to get out of his way and let him demo. Thank you.
Thank you, Todd. Good afternoon, everybody. So I'm Alan. My background is pediatric ICU, or also an Army critical care nurse. And not too long ago, actually, I learned about Accurate, and I was really intrigued. And I just want to briefly demonstrate here how simple it is to use. So you insert the Foley just like you would any other Foley, and you simply insert the cassette into the monitor. Very simple to do. You turn it on and you press play. You confirm that the catheter is in the bladder, and it automatically begins measuring urine. And the way it works is, what really sets it apart is the active drain line clearance technology that the monitor uses. So urine is constantly being pushed along the drain line against gravity into the cassette. The automation is really what nurses love about this. We are so busy. We're constantly, like Todd mentioned, about 125 tasks an hour. We're constantly being asked to do more and more. You know, if we're not taking care of patients, we're sitting at a computer documenting. If we're not doing that, we're having to keep track of other metrics for the hospital. It's always one thing or another. And one of the more tedious things that we're tasked with doing every single hour when we have a patient with a Foley catheter is making sure that the urine isn't sitting stagnant in the loops. So we have to milk the Foley, of course, and Accurate completely eliminates that challenge for us, which nurses love. The accuracy is really built in, as I said, with the active drain line technology and the sensors that Accurate uses. We use ultrasound and pressure sensors so that we can deliver automated urine output to the 1 milliliter. It's that active drain line technology also that helps reduce the risk associated with CAUTI. So some of those features include our silicone catheter. So there's no latex silicone catheter. We have 2 one-way valves. So even when the Foley catheter system's not in the monitor and actively draining, it's still not going to be flowing back into the patient's bladder. So that's great. And go ahead. Like I mentioned, there's no need to milk the Foley. The urine is constantly flowing. So one of the great things that Accurate also provides is AKI alerts, automated AKI alerts. So based off of the urine output, we can now tell you to the second when your patient meets the KDIGO criteria for stage 1, 2, 3 AKI based off of oliguria. And studies show that generally speaking, AKI is going to be detected by oliguria several hours well in advance of your routine serum creatinine levels. And we know time is brain. In the neuro setting, when you're talking about stroke, time is brain. And same thing in the cardiology setting. Time is brain. If your patient has a heart attack, time is of the essence. And there's no reason why we shouldn't have the same mentality when it comes to the kidney. We know that as the kidneys perfusion decreases as the kidney suffers more and more damage. The longer it takes for us to intervene, the worse the patient outcomes are going to be. We know that as AKI progresses, the length of stay for each patient is going to increase. Of course, this leads to increased hospital costs. And so the earlier we can intervene, obviously, better for the patient and better for the hospital. So here, so some data here. A lot of AKI goes undiagnosed if you're just looking at serum creatinine. It really underscores the value of having timely and accurate urine output data. Of course, as I mentioned, there's going to be increased length of stay associated with the progression of AKI, and we know that AKI deaths are preventable in a substantial number of cases, and CMS is now aware of this. And so I'll let Ashton touch on that here in a bit, but we've gone from this manual process where nurses are tasked, every hour they have to take at least a couple minutes typically, making sure that the urine is flowing through the catheter, through the drain line, and eliminating those risks associated with CAUTI, and then transcribing that data into the health record, into a system now where we have real-time data that we can integrate into your electronic health record that provides real-time acute kidney injury alerts. This can make a real difference in the care of our critically ill patients. With the data that this provides, it enables clinicians to make those clinical decisions in a more timely fashion. One of the other things that Accurate provides is continuous intra-abdominal pressure, and I think the work that the O'Brien Center is doing in this space is really integral to what the rest of the country is going to end up doing, because intra-abdominal pressure is something that I think I, as an ICU clinician, didn't pay too much attention to, and I think the more that we pay attention to it, the more we see the impact it can have on preventing AKI, because we do know that as the pressure in the abdomen increases, that is going to have effects on the kidney's ability to be perfused. So with Accurate's continuous intra-abdominal pressure readings, we now have another tool for clinicians to say, well, what can we do to maybe decrease the intra-abdominal pressure in the abdomen? And if we can't do that, how can we improve our patient's hemodynamics so that we can ensure that our patient's kidneys are being perfused? So here on the screen, you see a screenshot of what the monitor looks like when it flashes an AKI alert. You can see the AKI alerts are, of course, based off the KDIGO guidelines, which are weight-based guidelines. And so this allows like I said, the nurse to notify the provider, hey, my patient's urine output has been declining. The monitor now alerted me, patient's now in stage 2 AKI. And that's actionable data. So as I mentioned, this system was also designed to address several of the risk factors associated with CAUTI. So some of the CDC guidelines to maintain unobstructed urine flow, prevent movement and urethral traction. So because there's no urine being retained in the bladder, it's constantly flowing, we reduce those risks with active drain line clearance. We have a couple different catheter options, but 2 of our main catheters are permanently bonded, so that way there's no disconnection between the tubing and the Foley catheter, and we use silicone catheters as well.
Okay, thank you, Alan, for that. Just shortly, I want to touch on the CMS guidelines. So they recently changed. Starting in 2025, it's going to be voluntary reporting for AKI, and then by the year 2026, it will be mandatory to report stage 2 and 3 AKI. So this is very important to note because it is following the same path that CAUTI took I think it was 12, you said, Todd, right? 12 years ago. So it's really important for some hospitals to get ahead of it. so that they are trained on how to avoid AKI being a penalization for their hospital. So this is just touching on how many lives could be saved. AKI is a real problem. 300,000 patients die each year from acute kidney injury. And the average cost for that is anywhere from 27 to 50K for a patient progressing to stage 3. Todd, I think you had one more point you wanted to make on this one.
The thing that got me, because my dad died of cancer, is when I read that more people die from complications related to AKI than colon, lung, prostate, and breast cancer combined every year. And so what I've been scratching my head on is what's causing that? What is it that we could do to better protect the patient by giving the clinical teams the things that they need? Remove the manual work, give the data insights, and I know UAB works so much on using the right data. I thought that there has to be a better way of doing it, because if 300,000 people a year die with complications related to it, then it means it's a great opportunity to innovate around it, which is one of our big motivations when I worked at my last place to start bringing it in, is to, we have to do something better. And I read from Definitive Healthcare, you probably have heard of that data. For 2022, their data estimates that 4.9 million people in the country got an AKI diagnosis. So the geek in me likes to do the math. That's a patient every 7 seconds. Think about that. That's so many. And so there's no way that this isn't a great opportunity to at least start reducing that number as aggressively as we can. And the thing that, where my mother was a nurse until she was 75, the thing that concerned me about a lot of the work that we see, we continue to put the pressure on the clinical teams to do something different versus take work off their plate. And if the kidney's still manual, why couldn't we digitize it like the heart, brain, and lungs? It just didn't make any sense to me. And so that number tells us a lot about the opportunity to do something different, but not ask people to do something different, but to give them a device that removes the need for them to do anything and gives them the information that they actually need. Yeah.
Perfectly said. And just to finish, this is just to prove that what we say the device does, it does do. We are currently in 70+ hospitals. Here's an example of some that we are in at the bottom, and we recently surpassed the 85,000 procedure mark. So we have some great things going, and we also have a couple of really great studies and publications done just to prove that we do have happy customers, happy patients, happy nurses. We'd be happy to share those with anybody. They include a children's hospital, a burn unit, and then multi-site studies. So those are great resources as well. So
Thank you so much.
thank you.
Do you have a question?
How do we get out of
We're gonna
this?
monitor.
Stop the screen share. Okay, so thanks to Todd and the team, really appreciate that. I mean, I think a really great solution to a really big problem that we face. Okay, so any questions from those within the room and those who are on virtually? Carlos?
I'm just curious, what's the cost of the unit? Or, price range?
So the cost differs. We have many different options and different costs. We like to just base that on each individual hospital. We look at the data and we give them a return on the investment before we give them like the prices. It really just varies on what the hospital needs, how many monitors, how many beds they have. All of that is really important when we do give a price.
Some hospitals lease them, some people capital buy them. So one place I worked at would only do capital purchase, they would never do a lease. Another system we're working with will only start with a lease. And so, yeah, we have the dialogue with you, it just absolutely depends on the way your value analysis committees build it out.
It is important to note, like the value that it has, it's gonna be one of the least expensive things that you ever have in your ER or ICU or 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 ICU. It really helps, so.
You mentioned the connectivity to the EHR. Can you tell me a little bit more about that? Is this a direct connection to the EHR? It's any sort of monitoring systems or outside of the EHR, or is it fully integrated?
So it connects through the middleware, so it depends on each system's middleware and how we connect.
You probably run Capsule here. You probably like capsule. You can get it wirelessly, but like Philips capsule, there's Neuron, there's capsule. Capsule is the one that's more open. Neuron is the one that's a Microsoft interface. It can run through there because it's basically, think about it, it's an HL7 format. You can grab any piece of data that you want off of it.
But the data lives on the system. Is it fetched or is it sent?
Now, that is a technical question that I don't know, but I actually believe that you can determine which one it happens. So how often do you want it?
Yeah.
Do you want it every hour? Do you want it every 15
Exactly,
minutes?
these are the sort of questions.
Yeah, you can determine
Yeah.
that. We just met with a system, another big system, and they're just gonna grab it to the standard. They're gonna grab it to the standard, having to know urine output every hour.
Right.
And then once they know more about what to do with it, they said they can increase the frequency. But what they wanna do is just match what they have to have today. And so it can be sent then, or you can grab it then. Now, the data can live on the machines, like power goes out, whatever, the data can live on the machine long enough, if that's what you're also asking, so, but it doesn't go to any other servers like at Akron, if that's what you're asking also. No.
Well, I'm just asking, so it's connected to a network.
Yes. Yep, connected to the network. Connected to the security of your network.
If you need someone to hack into it and test the security of your system.
That's you?
We can chat afterwards.
All right, we'll call you. Great question though.
Great questions, yeah.
I had a question. It's been about over a decade since I've been in a clinical environment, but I was curious there on those numbers. Are those a combination of patients that are coming in and nosocomial infections, or is it just patients that are initially coming in that have the AKIs?
The data that I have from Definitive Healthcare is made up of two buckets. It's actual reported data to CMS of inpatient diagnosis of acute kidney injury. And then what they do for the rest of them is they look at your payer mix and patient mix, and then they kind of determine an answer. So it's only inpatient diagnosis. When that diagnosis happened, it happened in the hospital, but when, I don't know.
Okay.
That's the question you're asking me. Is it an inpatient diagnosis, or did I know they had a kidney problem walking in the door?
Essentially, right? Are they contracting it within the hospital, or is it they're coming in with it, right?
So diagnosis, an inpatient diagnosis of acute kidney injury. And are you because the other part of the question I hear you asking me is like, do they have chronic kidney disease when they show up and do we know
Right.
it? That's supposedly not in the number.
Okay.
But I'm digging on Definitive too to make sure I know. So, but this actually leads me to a question or an answer that I think is even far more appropriate. So I've talked to, I think, we have 33 people in HIPS now.
Mhm.
And the ultimate answer, the right answer to the question, 5 codes in 17, 17.1, 17.2, 17.8, and 17.9. Those 5 codes, if a system pulls those codes, you will know how many patients you diagnosed in your hospitals with an acute kidney injury. That's the most accurate answer. So we say, we think it's this because Definitive Healthcare says it, but go pull your own data and then you will know exactly what it is.
Got it.
So that's the better answer actually than me trying to, I know how many AKI cases Definitive says that UAB had, said the St. Vincent had by hospital. But your data is the source of truth, not theirs. Yeah. And I found a hospital the other day, I won't tell you which state, because you can figure it out. Definitive was actually under the number, which I was surprised, because most of those algorithms kind of overestimate things. Definitive was under the number of total AKIs for so about a 10 hospital system.
Okay.
Yeah, but I can send you the codes. Yeah.
Tom, you have some pre and post data for AKI and CAUTI in the organizations in which you install.
I know Alan and Ashton will have a better answer for this, but I know if you talk CAUTI, there are 2 studies that I'm very aware of. Children's Hospital of Atlanta, 3 sites, did a study. They went 512 days without one CAUTI. Pretty
Accurate.
on Accurate, yeah, because they put Accurate everywhere. They just fully deployed it. And then there is a burn center in Tennessee. It's called, the lead investigator is Dr. Brockway, and they reduced their CAUTIs by 90%. Yeah. And then I know there are a couple of other studies. Dr. Khanna did one on intra-abdominal pressure. I think they published 2 years ago. We could share that with everyone. And then there was a study that came out in June about Akron's ability to predict AKI 33 hours in advance of a serum creatinine score. It was really interesting, right? Because it means serum creatinine can lag injury to the kidney, but knowing urine flow sounds simple, but it's not, right? Actually could tell you 33 hours before a serum creatinine test tells you that you've got AKI starting to progress. And we could share that. Those are the 4 that I know, and I know another system in California is about to produce one on acute kidney injury. So yeah, there's peer-reviewed studies, multi-site studies, the last 2 with CAUTI,
Yeah,
are
yeah.
multi-site studies.
I guess that's where the rubber hits the road, isn't it? I mean,
That's where it is wrote.
yeah, absolutely. So I don't see any more questions from the online audience. Any final questions from the group? Okay, Todd and team, thank you so much for this.
Yeah, thanks for having us.
Yeah, thank you.
Hopefully close out the year with
Yeah,
useful time.
yeah, and we're looking forward to working with you on this, and hopefully we'll see you here much often.
Thank you.
Okay,
Thanks for
thank you so
having
much,
us.
guys.
Thanks a lot. Have a great
Thanks,
weekend.
thank you, guys.